Abstract. In this lab report, we're going to show you how gravity affects all objects that are tested by a free-fall experiment. We're going to test and show you the results of the fall of some spheres in different sizes and materials that when we test them on our experiment, we prove how gravity affects them all. So we can show it is uniformly accelerated when it's falling and how this acceleration does not depend on the weight of the object. Finally, we're going to show you how is the gravity in an experimental and theoretical experiment for the city of Culiacan. Introduction. Free fall of an object occurs when the object is falling and is under the sole influence of gravity. In a free fall motion, the acceleration of the movement is gravity itself, meaning they accelerate downwards in a constant rate of 9.8 meters per square second. The study of free-falling bodies has helped us to determine in how much time will the object impact with a surface, but also to determine its velocity when the impact will occur. The study and theories of free-falling objects have been around the world for a while. For example, Aristotle said that the heavier objects fall faster than the light one, but a few years later, Galileo Galilei wasn't agree with that. Galileo speculated that in addition to the force that always pulled the objects down, there was an upward force exerted by the air. As we can see, there are many factors than gravity to establish when an object will fall. By this, we can say that the hypothesis of this lab report is gravity is not a constant value on
materials, spheres, free fall machine, smart timer, scientific calculator.
Meta description.
First, we did a historical description of falling bodies using a sheet of paper and a piece of clay. The second step was to do a detailed explanation of the gravitational force and the factors that affect the objects that were falling. Then the third step was to calculate the time of reflection. The fourth step was the theoretical determination of the acceleration of gravity in Culiacan based on geographical coordinates. And finally, the third step was to test the free fall of the objects 3 times each, and we recorded the results.
Results. Using the formula for gravity, we'll calculate how gravity affects on Earth, in the North Pole, South Pole, equator, and on Culiacan. On this image, there are shown 4 experiments, with 4 spheres: the silver sphere, the yellow sphere, the gold sphere, and the big white sphere. We calculate the time on 3 samples, and then we calculate the gravity by a formula given by our teacher. Result discussion. According to the following results, we can say that gravity affects all the things on Earth, according to the mass, volume, and weight of them. But what is gravity? Gravity is the force that attracts a body towards the center of the Earth, or towards any physical body having mass. This was said by the Oxford Dictionaries on 2015. On the results, we can perceive that the average gravity is different, even if we make the experiment at the same distance. This gravity means affect all things depending on where it is located, that mass it had, and the time. For example, here at Culiacan, gravity affects things different than in Paris. This is because we live the world in 2 parts, when some countries or city will be apart from the x or y axis. In brief, gravity is different on Earth.
In conclusion, in this practice we learn about gravity and its varieties. For example, before this practice, we believed that gravity is constant, but no, gravity is a variable on Earth that can affect all the things that have mass, volume, and weight. That is important to us because we all are on Earth and we should know how gravity affects us. By this, we can say that our hypothesis that says gravity is not a constant value on Earth is valid and acceptable due to all the experimental and theoretical experiments we did in the lab.
Questionnaire. We answered this brief questionnaire by using the following formulas and our rational thinking.